This towage portion has been removed from a grid roller because it needs repairing. To have a better understanding where it's from, here's a grid roller I've previously repaired. I'm going to start by stripping down the towage portion to see which parts I can reuse. This nut is still functionable. This washer is functionable, and what's left of the spring can go to the scrap. This spring is still functionable, as well as the washer. The towage shaft is worn, so I'm going to start by making a new one. I'm improving the design of this grid roller towage portion. The previous towage shaft was made from Iron 8 steel. It is a soft steel, and I don't believe it's good for this application. I have decided to go with induction hardened chrome shaft. I'm also changing the design on the portion that houses the shaft. I'm going to insert hardened bushings in that portion. These two materials work in all heavy machinery, so it will definitely be suitable for this application. That's all the machining needed for the shaft. I'm removing the old hitch as the customer requested that I reuse it. I cleaned it up with the grinder and tacked it straight with the shaft. After that, it was time to weld it together. In the customer's defense, I believe an oval hole in this hitch is alright. You get hitches with attachments that allow it to pivot up and down. This grid roller does not have one. So this worn hole is allowing the grid roller to pivot. And that's the towage shaft complete. I now need to repair the portion that houses the grid roller towage shaft. I'm going to cut out the boss, fabricate a new one, and weld it back into the housing. As mentioned before, I'm slightly changing the design. I'm going to insert replaceable hardened bushings into the new boss. The hardened bushings, together with the induction hardened chrome shaft towage, will outlast the original steel-on-steel design. It's also an advantage that the bushings are replaceable. With the previous design, any wear resulted in a major repair. Another difference in this design is I'm adding a grease port. Grease will reduce the friction between the shaft and the bushings, resulting in longer operation without wear. The turning for the boss is complete. It's now time to fit it in the housing. It was slightly too big for the holes I cut, so I used a grinding disc on a drill to grind out the high spots. Next, I made sure it was positioned correctly in the housing. All was good, so I dropped the hood and started welding. When the welding was complete, I let everything cool, then pressed in the hardened bushings. Both bushings fit perfectly. It was now time to drill for the grease port I mentioned. I machined this little bush to tap into the boss and sit countersunk in the housing where the grease nipple is located. And that's all the work for this towage portion. I'm using 2 of the old washers, so I cleaned them in the lathe. I also made another 2 washers I want to add. It's now time to assemble everything so the customer can collect. If you've enjoyed this video, don't forget to like and share. As requested, I'm trying to put more attention on my YouTube channel, so subscribe, it will be much appreciated.